Now we're going to go over your lab for the week. And because working with the normal distribution is such an integral part of the remainder part of the class, this lab is going to be just more problems on having you work with the normal probability distribution and a few on uniform probability. So you'll be able to pull up the lab. You'll have to print it off, complete it, scan it back in, and upload it into the document. The first couple questions do deal with the uniform curve, and it gives you the picture here. Remember, calculating probability with a uniform is just a matter of calculating an area of a rectangle. And then for the next ones, we're going to calculate normal probability. The normal probability will be like the last examples that you did in the example video, where you're given a mean and a standard deviation. So you're given a mean. You'll be given a mean and a standard deviation. And some value that we want to look at and a direction. So we're looking at greater than 0.32. So in this type of problem, the 0.32 would be an x value, the mean would be a mu value, and the standard deviation would be sigma. And you'll do like we did in the last example in the example video to come up with a probability there. Number 4 and 5 work similar in that you're given a mean, a standard deviation, and an observed value with a direction. And in the next one, you're given a mean, a standard deviation, and an interval. So you end up with essentially the 3 problems that we worked at the end of the example video put in slightly different context. Rather than just giving you the values, we give some context to the problem. The next couple are similar to what we did with the finding the z-score and then converting that to a value that goes with a particular problem. I do want to give a hint on 6 and 7 and work another example like both of those in this video. Okay. So what we're going to do now is an example where I talk about the, let's suppose we want to find the z-scores that correspond to the top 10% and bottom 10%. So in other words, what I want to do is find the z-scores for my normal distribution where there's 10% above and 10% below. So I'm capturing the middle 80%. So I want to find this z-value and that z-value. Well, I'm going to go to my normal table. And I'm going to look in the body of the table. You have 2 ways you can do it. One would be to look in the body of the table for 10%. So I'm going to try to get as close to 0.10 as I can. And that happens at 0.1003. And I notice that that is at a value of minus 1.28. Because of symmetry, that gives me 1.28. So the two scores that go with the bottom 10% and top 10% are minus 1.28 for the bottom 10% and plus 1.28 for the top 10%. Again, notice we have a nice symmetric picture. So these are going to be at the same point, just different signed, because we know that 0 is in the middle. And we looked up 10% to get that number and used the symmetry to come up with that. Alternatively, we could have said, okay, being in the top 10% means that 90% lie to the left, and we could have looked up a value of 90% in here, which we know from our previous example was at 1.28. The next example I want to talk about is a relative scale. Let's suppose we have a score of 30 where the mean is 25 and the standard deviation is 5. We want to convert that to a scale where the mean is 90 and the standard deviation is, so this is mu, and sigma equals 10. Oftentimes you have a situation where, take a standardized test, where they change the format of the standardized test and the scoring rubric that they had before is no longer appropriate. But they want to have a way of comparing people who took the exam before the change to people who took the exam after. So they may have a conversion that will do that for them. And essentially what we're doing here is we want to get the same relative position. So what we mean by that is the number of standard deviations that this score is away from the mean. We want to find the corresponding score that's the same number of standard deviations away here. So in other words, we want to say, okay, 30 minus 25 over 5 is 1 standard deviation away. So the mean mu is 1 standard deviation away, or the score of 30 is 1 standard deviation away from the mean of 25. What we want to do is convert that into a score based off of a mean of 90 and a standard deviation of 10. So that would give me that x is 100. So under my new scale, we would have a score of 100. So that's an example similar to what you would see for problem number 7. Problem number 8 is kind of like what we did with the between two values, and so is number 9. Number 9 is very similar to this example. They're trying to find a z-score that corresponds to some probability, and what we are given is the middle probability of 0.4314. So that's 43.14% in the middle. That means you're going to have 56.86% on the outside of that. split evenly between the two ends. So you'll have to try to draw a picture that looks like this, where the middle is 43.14. Now figure out which would go on each of these, and that will help you determine the z-score. For number 8, you can use the fact that the probability that you're less than 0 is 0.5. So to find this A, it really means I have a picture that is like this one, except we're going to have this is 0.4608. Now we already know that this is 0.5. So going below gives me 0.9608. So this is the value I want to now look up in my table. And the next three are similar to the percentile problems that we had. And it may be multiple steps in it. So for number 11, you want to find the probability of being more than 1 standard deviation away from the mean. Well, that corresponds to a 1 standard deviation away from the mean. Another way of saying that is I want to know the probability that z is less than -1 or the probability that z is greater than 1. Not very easy to read, but again, kind of hard to write with the mouse. So this was what it means to be more than 1 standard deviation away. So you'll have to find both of these probabilities. Because they're disjoint, you'll add those together. Now, the empirical rule should give you a hint on that. Remember what the empirical rule says is being within 1 standard deviation is approximately 68%. So being more than 1 standard deviation away should be close to the opposite. On number 11, that's again using this idea that we have z equals x minus mu over sigma. You're given a z-score, or you're given a percentile. From that percentile, you can come up with a z-score like we did in our examples at the beginning of the lab here. You are then also given an x value, you're given the mean, and you can then evaluate or find the standard deviation by solving this equation for sigma. On number 12, you're going to do something similar, but you'll do it in 2 steps. I'm going to do the same process where I'm going to find the z-score that goes with the 75th percentile. You can use what you came up with from 11 for that. I'm then going to find the standard deviation for this particular set using these values of the mean and 75th percentile. That will give me sigma, and I will find the value at the 90th percentile. So I'll go back and finish that problem up by doing in the examples that I did in before lab, we did one where we found the 90th percentile of something. So then you'll incorporate that here. So it'll be a 2-step process. you will first have to do z equals x minus mu over sigma to come up with the sigma value. I will then use the z-score at the 90th percentile, plug in the mean that you know is 71, the standard deviation you will have calculated, and then come up with an x value. So once I solve for sigma, I'll then do x equals I'll then do x equals mu plus z sigma. But you'll use the z value for the 90th percentile instead. Once you complete this worksheet, please upload it to the lab section.